Hello and welcome to the Tevora webinar, Leveraging Provable Security, Achieve Security Assurance in the Cloud. I'm Kevin Cutter of Tevora's account management team. Today, Chris Callis, Tevora's cloud practice lead, will outline the need for provable security solutions, speaking to how the utilization of mathematical logic can bolster your organization's security stature. Prior to getting started, we'd like to point out if there are any questions throughout Chris's presentation that you're welcome to ask them at any time. Please utilize the chat function available for your benefit on our webinar platform, GoToMeeting. Chris will look to address all relevant questions during his live presentation. Any outstanding questions asked by our audience that remain unanswered will be taken care of at the conclusion of this webinar. Before Chris kicks this off, I'd like to share a bit more about Tevora, for the benefit of the audience members that are still getting to know us. Tevora is an information security management consultancy with a pure focus to information security, risk, compliance, and solution services. We have 17 years in business as a pure play to IT security. The Tevora consultancy was built to handle the most challenging environments. Year over year, we've refined our methods to remain on the forefront, protecting our clients on everything from malicious threat attacks to new cybersecurity regulatory standards. Regardless of your needs, Tevora looks to partner with its clients from the onset, a trait many of our repeat customers say sets us apart. We have 100 information security consultants on staff nationwide, specializing in the full spectrum of InfoSec services, inclusive of compliance, enterprise risk management, data privacy, threat management, incident response, solutions, and of course, the reason you're all joining us today, cloud security. With that being said, Chris, the floor is yours.
Perfect, thanks, Kevin. And just want to welcome everybody to Leveraging Provable Security to Achieve Security Assurance in the Cloud. Before we start diving into what is provable security and security assurance, let's just do a little recap. From a cloud security perspective, we've done multiple webinars, and I'll provide the link at the end of this presentation that you could go back on and see the foundation that we built on. Some of this is going to reference that material, and we'll kind of take it from there. So from a recap perspective, what we did was we were talking a lot about infrastructure as code and codifying, your workload to have a repeatable process that allows your workload to scale within the cloud. As security practitioners, our goal is to build and operate secure systems. But we need to take a step back and ask, what does it mean to be secure? Initially, when you're thinking about what does it mean to be secure, break it down into maybe two variables. Bad stuff doesn't happen, and maybe my boss keeps paying me. Over the years, this approach has really evolved, and kind of taking the stance of, ensuring wrong things don't happen. But when you take the stance of wrong things don't happen, some organizations may go down the path of mixed cement and cable cutters. So, we need to find a balance between the two. And we kind of end up at right things do happen. But what does it mean to have right things happening within the environment? How do we measure that and go forward to ensure that the systems and our architectures working the way that it's been designed? So we want to check a couple of things. We want to make sure that our systems exhibit only desired behaviors, or they should exhibit only desired behaviors. This is all done through, more structured, formal structures that are currently taking place. We want to make sure that they exhibit these desired behaviors in all reachable states after processing any data inputs for all given starting states. Being a cybersecurity consultancy, we help many organizations with various security needs and requirements. We can certify against most three-letter compliance requirements. We have talent and fingers on keyboards to provide that security assurance, through our penetration testing and our red teaming services. And we have a fire team to, respond to incidents and do what they do best. Over the years, though, we're starting to see this, the way that these things are done, shift. Over the last couple of years, PhDs have been entering this security field and talking a lot about these SAT and SAMT solvers and how they could be used for any problem, even security. And this is solving these issues using formal methods. They were wrong in some of the parts, but they did bring some interesting ideas, which we're starting to see a lot of adoption with the various cloud service providers out there. So let's talk about architecting security workloads. I don't need to preach about the amount of people that it takes to know how to do the right things to secure your workloads within the cloud. You have your infrastructure, which changed drastically from going from your typical Cisco, maybe Palo Alto type environments to your EC2 security groups and your VPC ACLs, and what that actually looks like in the cloud between the various cloud service providers. They're all doing it a little bit differently. From a systems perspective, underlying Windows and Linux systems, those are pretty much stayed pretty static over the years, but we're starting to see adoption with serverless, not having the responsibility for managing those systems and needing to have the right resource to know how to leverage things like Kubernetes, Docker, those type of technologies. The applications for the underlying technology stack or the tech stack that exists. Identity. What does identity look like in the cloud? You used to just have like your Active Directory or your LDAP folks. Now, you need to know and specialize within IAM within AWS, identity access management within Azure, and so on. So, what we're seeing here is technology is constantly shifting. People are learning new things. It takes a whole group of people to do this. And one thing that we've seen is it never looks the way that it was intended from the design phase. Customers want a particular use case that's going to, break everything within your workload. Features requests come down, Heartbleed and Eternal Blue vulnerabilities come out at 2 o'clock in the morning. And then to top it off, your CEO just read some article in the New York Times and now needs your team to start building this right away. So let's take a look at some simple architecture right here. SSH represents, management traffic. Blue traffic is represented as the web traffic they're expecting to come in. These properties from architecture should always be true. It's straightforward, right? How could this ever be complicated? But just like we know, no system is static over time. Alterations are a daily process, and this causes growth. Especially with technologies like Kubernetes, serverless type stuff, you have systems that are constantly spinning up and spinning down. And when we're evaluating these technologies within organizations, that presented some interesting compliance issues in terms of, hey, we observed, SSH wasn't hardened in these 3 systems. To find those 3 systems no longer exist within the environment. So how do you ship with it and kind of go along with, all this new technology that is coming out? And then sometimes on top of all this complexity, you get a Kevin. And Kevin is some random server under Kevin's desk. And Kevin just wants to assure you that this is temporary. And it doesn't matter if it was the right or the wrong thing at the time. Now it's 15 years later, everyone's wondering who is Kevin and why is Kevin running a Windows 2003 servers? And state changes, they're not just unique to technology and into your workload. New York, they're talking about speeding up the trains, and to do that we got to fix traffic signals that haven't been touched in 2 decades and nobody quite knows where they're at. My brother bought this B5 S4 because he loved the car. We get to the service manual, we look under the hood to check it out, and the vacuum system looks nothing like it's depicted in the diagrams. Things are rerouted, they're unplugged, there's missing components, and there's one thing that we know for sure from a state change perspective is the Germans did not design it that way. So how do we move forward from this? Let's talk a little bit about security assumptions. Within security, we break down these security assumptions into 2 categories. Traditionally, we try to violate our assumption that something is supposed to be secure. And we try to spot our assumption, knowing that the environment's hardened to X, Y, and Z standards. This is traditionally done with technology and services like penetration testing, fuzzing, social engineering, various ways to try to prove that something is secure. And these break down into their corresponding transition states. Transition state is a way to reach states that you assumed were not reachable. So, before we kind of position this talk within Tevora, everyone was like, now Chris, hold off on the math and just let's keep to what makes sense. So keeping it at a high level, when we're talking about transition states and provable security, provable security is quite simply using mathematical logic to prove that a desired set of properties of infrastructure are in place. And when it comes to math logic, as deep as we're going to go is it's a foundation of truth. There's knowledge, there's reasoning, and we want to have some type of finite argument that establishes truth with that type of reasoning. Essentially, we want the Pythagorean theorem for your infrastructure, something that's been around for thousands of years that hasn't been proven false yet. So with that, we talk about ways to try to reach a violated assumption with your security. So there are a couple ways, ideas to reach these transition states in our traditional testing. One is through penetration testing. 105 drop table. An organization did not expect valid SQL snippets injected into their data plane input of their web form. And hopefully a creative person on your team, or you hired somebody like us, came up with the idea to test it to ensure, maybe you're parameterizing, your queries. So, if this is 2000 and you're behind on your OWASP top 10, if you didn't do these things, you may have just lost the customer field within your database. Cross-site scripting, in this PowerPoint presentation, this is a simple way to test cross-site scripting. But, if it is an unexpected input into somebody's, web browser without the right protections that are in place, all of a sudden they're executing code. Fuzzing is another way that people do things. Essentially fuzzing comes down to unexpected input leads to unexpected states. At a high level, we do things called a binary tree analysis. Essentially, we're throwing a bunch of data at maybe, for example, a port. We're throwing 1,000 A's or 5,000 A's or 10,000 A's. So we keep on throwing A's and B's and Z's at it until it crashes, and we wait for that crash. And once we find that it crashes, we know it's not handling that data appropriately. It found an unexpected state, and then we could start carefully crafting those inputs and maybe insert a shell or do some other things with it. And the other transition state that we want to talk about is threat modeling. We're not going to get too much into threat modeling itself. I think we all have experienced the pros and cons of threat modeling in the end. Sometimes it's an abstraction from reality, and we run into this issue of how far down the rabbit hole do we want to go. So currently, in our current state of security and compliance, there's a balance of gaining assurance that your workloads are secure, specifically what we're talking about right here in the cloud. That's humans manually exploring state space, penetration testing, maybe fuzzing. It's fun, but it's slow. Machines randomly exploring state space is fun, but slow. That's your vulnerability scanners, maybe like SQL map or something like that. Threat modeling makes it more tractable, but too much detail in a threat model could lead to a state explosion and nobody knows where to start, and too little detail leads to a meaningful loss of fidelity. Oh, I didn't know that this certain service account had access to delete this table within the database, and all of a sudden everything's gone. So then we get over to automated reasoning. This is all about inferring future behavioral systems, what they will do and what they may do. And I'm going to hold up to my math promise that I made to you guys a couple of minutes ago. And what the industry is really in the process of is developing these mathematical proofs for your underlying infrastructure. So, AWS and Azure are currently developing proofs to translate what is a VPC, what is the internet, those type of things. And they want this, and then they hire another group that's not only developed it, but a separate group, kind of like a cryptanalysis, to actually try to break these proofs and show that they are false, to kind of hold up and help you prove what you need to prove. And these are done through tools like SAT and SMT solvers. These are all about exploring state space and asking questions that you want to satisfy. Maybe one of the questions is my environment reachable by the internet? Maybe the other one is my S3 bucket publicly accessible? With maybe fuzzing and penetration testing, the tester works forward to find the right value, but the state space is maybe it starts scaling to be too large to find the right answer. I know we have a lot of clients that maybe start off in a single VPC. Then all of a sudden, everybody else wants their own AWS environment. There's VPC mirroring all over the place, and next thing you know, they end up with 1,000 accounts and they don't even know where to start to manage these things. So it gets so large to find, it makes it hard to kind of find the right answer. So for example, with a state space of maybe 20 variables, you have about 1 million different possible combinations. When we're talking about automated reasoning, it works backwards. And how do I cause these technologies, work to try to cause the results that they want. And these SAT solvers, I mean, from my perspective, I don't know how they work underneath the hood, but I know that they've been used traditionally in, hardware engineering, aerospace, military, and aviation for quite a while. And these are now getting developed to work, within your cloud environments, and maybe without you guys even knowing that they're actually implemented yet. So let's take a look at that network diagram that we did a couple of months back. We have public, private, and a DMZ VP subnets with their appropriate security groups that restrict certain amounts of traffic. We discussed codifying the entire workload to ensure repeatable, secure environments. So when you do scale, you have some level of assurance that nothing is changing. So how do we, and we also talked about how to leverage tools such as AWS Config and Inspector to test and automate remediation. And if you guys go back to our Tevora webinars, you could pull down those. The governance in the cloud's the big one that really ties everything together. And there's videos and tutorials, and our YouTube channel also has those on how to deploy and what the results of those actually are. So what AWS currently has built out, one of their technologies is called Tyros, and that's built into AWS Inspector. And that helps you really answer those questions about, did you build the network that you intended? So for those of you that have compliance requirements, something like maybe PCI DSS 1.3, which calls out the need to prohibit direct access between the internet and any component in the cardholder data environment. So from a provable security perspective, we want to test the transition state that the PCI network has segmentation in place to prevent that type of direct access. And the controls that are in place from PCI to ensure that that's in place and it's tested as a manual review, an internal interview. So we have an idea of what that data flow looks like. And then we back it up with a segmentation test, which is a penetration test from a privileged location that has unique access to the CDE. You're testing from the perimeter in to make sure that no traffic across that boundary. And that's a really time-consuming process. And there's a lot of times where we'll go in, we're going to perform the test, people are up against a tight deadline, and all of a sudden, this rule is actually not in place and it's violated. And there's a lot of work that needs to be done to fix it. If only, there was something in place that could have let you know a long time ago that not only is there no access to the internet, but you could prove that there's been no access and that has not changed since your actual last assessment. And that's where those SAT and SMT solvers come in. So you could ask the questions, for example, like, does my CDE prohibit public access to the internet? Or what systems do have publicly accessible to the internet? In a traditional sense, they would have issues answering the questions like, what is the internet? And what is a VPC? And what is a route table? And that's where, from an industry direction perspective, each of the major cloud service providers out there have been, pretty much hiring all the PhDs that exist out there and developing their own secret sauce to really translate their infrastructure in a way that these SMT and SAT solvers can answer those questions. So AWS has probably been putting in the most effort into their secret sauce to translate these services. Microsoft and Google are also developing their own SAT-based techniques to kind of provide the same level of assurance. And again, AWS's technology that's built in is called Tyros and Zelkova, and these translate policies into mathematical language and use tools to check the properties of your workload. And these tools have been in there for quite a while. You may have noticed them when you've been reviewing maybe your S3 buckets. When that orange icon shows up, that's Zelkova, letting you know and testing to see if the S3 bucket is publicly accessible and letting you know that it's publicly accessible. Within AWS Inspector, this network assessment test, what's really neat about this is, it can let you know if there's ports reachable outside of your VPC. That's the biggest one that we like to check. And what's neat is it's able to come back to you and tell you what is accessible from the internet without sending a single packet through your environment, which is wild. That really helps organizations. That scales and really doesn't affect your workload, and it's something that you can run, which is really nice. Again, those technologies are covered in our previous webinars. I think specifically it's the webinar 3, governance within the cloud, and we dive into the actual technology and actually get into some of the how it works, how to have it configured in more detail, and we'll provide those links. So again, from an industry direction, we know that they're developing their secret sauce, and the secret sauce is really to help you answer questions about your workload state. So from our end, we've had a lot of clients wanting to bring us in to help them set up a solution to evaluate their environment on a continuous basis. So when you're using these tools by themselves, you start to want to leverage them a little more efficiently. You don't want to just be notified, depending on how much hands-on you want these technologies to have. People will either have it input into Slack if it does find a violation in the statement. We've been brought in to tie automation to automatically remediate certain things. For example, if they've codified their entire environment, the approved version of it's living in GitHub or GitLab, maybe we'll build out a Lambda function. So once maybe CloudFormation or whatever you decide to use pushes this out to the environment, if there is a change, two things actually occur. That kicks off an SNS topic, which kicks off a CloudWatch alert, which then goes to Lambda. And then, there's some Python that we do in there to roll it back to its previous approved state, which is really neat to see. There's other things where they want more alerting, but the more automation we're seeing is to ensure that the network is staying in a state that's approved, that kind of goes through the process, and that helps them maintain the compliance over time. And this continuous security strategy via change triggered evaluation is proven to be really popular, especially with clients that have SOC 2 requirements where, for example, PCI is just at point in time. SOC 2 requires you to demonstrate that these controls are in place over time. And with this type of provable security model and using these SAT and SMT solvers, that allows them to do this. So, it's up to the organization to decide at what point and how aggressive they want this technology to be in place. But in the end, it's at least going to let you know that something exists, which allows you to kind of go into your compliance assessments, having a lot more assurance and knowing that that surprise isn't going to come up and your deadline may get pushed and your customers may get angry. So where does this lead us? So, right now, the current state of provable security is, automated reasoning is great, but at the moment it's kind of expensive. It requires compute resources. Again, this is used to evaluate, very complicated environments. So it does take compute time, and that does cost money, especially with the cloud, where that's their main kind of way that they actually do their billing. Also, automated reasoning does not have judgment. So we could set up these tools and these technologies to alert, to respond. Each organization has like a slightly different posture on how involved they want it to be, but in the end, it's providing that visibility that's crucial. So down the road, we see it complementing organization security strategy, and we really just scratched the surface here right now. We definitely see a world where maybe your annual security review is going to turn into a biannual because you're able to demonstrate compliance so easily. We could definitely see a world where, these assessments don't take as long to actually perform, and remediation becomes a lot quicker. So it's going to be interesting to see how everything evolves over the next couple of years as more and more people adopt this. And it's definitely very exciting. Yeah. So that's provable security and security assurance within the cloud. Again, my name is Chris Callis. It's our GitHub with some scripts that we've done over the time, and I think that's the link to our Tevora webinars. If you guys wanted to check out, especially the governance within the cloud, that's a pretty popular one. Kind of shows step-by-step how to deploy some of these technologies. And I will switch it over to Kevin for the questions.
Yeah, thank you, Chris. It was a great presentation. It does look as though we have a few remaining questions before we wind this down. Question 1, can I use provable security for my entire security strategy?
Yeah, it's a big question. You could definitely have it complement your security strategy in some ways. I wouldn't say that, and if I'm understanding the question correctly, I wouldn't say that it has the ability to replace every single control, but a lot of those critical controls we see, like segmentation, are my systems actually patched in a certain way, definitely can leverage provable security and the technologies that are deployed into the various cloud service providers to help complement your security strategy. So it looks like it's definitely going down that direction.
Great. And the other one, I kind of laughed when this one came across because you were actually presenting on whether math would or would not need to be involved. So the question was, do I need to know math associated with provable security?
Yeah, no math is needed. Really, it's the back end that does all the math and the PhDs that they hire. Just like we saw with like the S3 bucket example, it's really working in the background, letting you know that certain things are true within your environment, allowing you to take that action. So definitely don't need to know the math. I think it's neat to know the load on the infrastructure that it placed and what's going on. So that's neat from my perspective, but definitely don't need to know any math. And I think that's one of the reasons that maybe we're seeing such a slow adoption within the industry at the moment is, a lot of the presentations that you go to Provable Security on, I mean, they spend maybe like half hour, 45 minutes talking about math. So I think that loses a lot of people initially, but then, if you stick through it and get to like the fun parts like this, it's definitely a very interesting topic.
Absolutely. Well, in looking that over, that's it from a question standpoint. So Chris and I would like to thank everyone again for taking the time to join us today. Your Tevora account manager will be in touch shortly to ensure that you received everything you were looking for from Chris's presentation today. And given the breadth and depth of Tevora's information security services, please do not hesitate to ask your designated account manager anything top of mind regarding our ability to be a valued resource to your security and compliance initiatives. So thanks again, everyone, and have a great week.
Thanks, everybody. Bye.